looking that for all the categories, the distribution of frequencies is same or not. So we are looking in the difference of the observed and the expected frequency. So we are talking about only count here. When we say variable, generally variable means the value the variable is having. In case of categorical variable, we are having the counts of frequencies. So count and frequency is one in the same thing. We are counting things. So that is the count, right? Next is the independence of attributes. So this is the next category of the chi-square test. When I'm saying independence of attributes, in this case, we will be having the two categorical variables, right? So in case of independence of attributes, we will be having the two variables, two categorical variables, and we can say categorical variables are nothing but these are the attributes of your objects or of your respondents. So we are looking for that these two categorical variables are independent of each other or not, or whether they are depending on each other. So this is the purpose of independence of attributes of chi-square test, right? So this type of test is generally checking whether the two attributes which you are considering of your respondents, they are independent to each other, or whether they are having any association or relationship. Is it clear? Friends, is it clear?
Ma'am, can you give an example with respect to management concept, please?
Yeah. For example, means if I'm not talking about management only, if I'm talking about the means, I'll take an example which can be easily understood by everyone. Suppose if I'm saying the smoking habits and the gender, right? I want to see gender is a kind of characteristics of any person, right? Habit is also a part of any particular individual's characteristics. So we want to see whether these smoking habits are depending on the gender. Means if a person is male, so whether he is more inclined towards the smoking, whether the person is female, so he or she is more inclined towards to the I'll talk you on phone, ma'am. So in that case, we will see that person is female, so that person is more inclined towards to the smoking kind of thing. So in that we want to see these two variables are associated to each other, or whether they are independent to each other. So when your outcome is coming as your variables are independent, that means your gender variable is not playing any role in deciding the smoking habit of the person. Is it clear?
Yes, ma'am.
Yeah. Now,
Ma'am,
yeah.
just like maybe I'm wrong also, like if we have null hypothesis and alternative hypothesis, the question which is actually going for null hypothesis, we will categorize in a one slot. Is it like that? And which is going for alternative, like one question, like same like example, gender and smoking. Now I can directly ask them whether gender is responsible for smoking or not. One question is there, then relatable maybe one or two more questions will be there. Will it be same category of null hypothesis or alternative? We will categorize on the basis of that, or it will be like one question for one hypothesis, another question for another hypothesis. I'm just asking you. Maybe I'm wrong also.
Okay. For example, the same example we have taken. Fine. So let's do a survey of our means in the this particular FDP participants only, right? Suppose, yeah, second. I'll come here. I need to check whether I can create a poll or not. Okay, not. Yogra sir, are you there? Yogra sir, are you there? Can you make me the co-host of the meeting so that I can create a poll? So can you make me the co-host of the meeting? For I need to make a poll. Yeah. So I want a genuine answers from every one of you. I'm only asking the two questions from you, and that way I think you will get an understanding what I'm saying you through that hypothesis, right? So give me a second. I need to check whether I have got the no. I've not got the rights to create a poll. Okay, sir. Thank you. I can start. Okay, so I think first question I have asked you, you people can go to the activity section and check the poll and then respond. I'm writing the second question. Two polls I have launched, only 6 responses I received for the first question. Okay, I think please respond fast. There are almost 36 respondents, including me, Ajay sir, and I think Yogra sir. So we three can be eliminated. At least 30 responses I need to receive here. Okay, no one is smoking. Okay, fine.
Ma'am, where do we find that activity, ma'am? Can you guide us?
Near to your that chat option, that three icon is there, that rectangle, square, and the circle. That is the activity section.
Yes, ma'am, but I don't find any activity. Is it in that tab?
I think because I have launched, so I can see. I don't know. Anyone who can help, ma'am, Pooja, ma'am.
So, ma'am, even I can't get any activity in the chat box, ma'am.
Not chat box, ma'am. Next to the chat box, there is one more icon, activity icon.
Ma'am, I have gone into the activities. There is a
Yes.
tags, people, info, and
Yes, poll.
activities.
There is no poll.
In
No,
that
I
activity,
don't find.
in that activities, we have poll. Two active polls are there. Two questions is there.
I don't find any question. Give me a sec, ma'am. Give me a sec.
No issues. It is not mandatory for all, but only I need some data in this. So 12 of you are saying no for this move. No problem. Shall I proceed? I'm stopping the poll now so that we can.
Yes, ma'am.
Yeah. It's better you respond to both the polls, because as at one place I'm getting 11 votes, at one place I'm getting 13 votes. It should be equal. Both in both the places we need to have the equal responses. So please respond to both the polls. Those who are responding. Okay. One more poll. I think one person has not voted for the gender selection. So whatever your gender, please opt for it. Fine. No issues. I am ending the poll. I think it is done. I have ended both the polls. Yeah. Now I have ended the poll. I don't know who was interacting that time to me. May I know the name?
Ma'am, Pooja here.
Pooja ma'am. Pooja ma'am, I think according to your question, as you asked me, so we have, suppose I am developing a questionnaire and I have put these two questions in my questionnaire, right? I'm asking the gender from the person, I'm asking whether they are smoking or not, right? So everyone has responded their gender, everyone has responded their smoking habit, or whether they're smoking or not, right? Now, I have identified, I don't know whether you're able to see the poll results or not. If you have not seen, I'm reading for you. I have received total 14 votes for the gender question. In that you can see, or maybe I'm telling you, there are 4 males and 14 females, right? So I'll come here in my, this I can write, I'm having male, female, and then yes and no, right? So how many males I'm having? 4, and I'm having 10 females. Done? It is okay?
Yes, ma'am.
Similarly, when I am looking for the question I asked, do you smoke? So one vote I got for the smoking. It's yes, the person is smoke, and 14 votes I got for the person is not smoking. So although the ratio is not correct, it should be 14-14. So I'm making it 1 and 13. But I don't know who has said yes for smoking. So maybe I'm considering any male has said he or she is he is smoking. So out of four, one is smoking and three are not smoking, right? Similarly, out of 10, no female is smoking, and all the 10 females are saying they are no, not smoking, right? So this way my data is prepared. Clear?
Yes, ma'am.
Yes, ma'am.
On
Yes.
this data we can perform, then I'll let you know further how you can go for the this performing of the chi-square test. So after this, after understanding the concepts of independence of attributes, now you need to see how to make your hypothesis. So the way of making of hypothesis is, there is no association between categorical variable 1 and categorical variable 2. Means two variables are not categorical variables, are not associate. Or other way around, you can make your hypothesis as your categorical variable 1 is independent of categorical variable 2. This can also, you, you can make or you can write. Both the ways or both the things are almost similar, right? So this way, these are the two types of chi-square test. Chi-square test, I'm repeating those who joined late, chi-square test is a non-parametric test. Generally, the purpose is we want to see whether the frequency distribution is uniform throughout all the categories of the categorical variable or not. So you need to see the distribution of the frequencies. For the purpose of making you understand, as ma'am asked me, so this example I have taken for the color preferences, and then I explained to you what is observed frequency and what is expected frequency. Then talking about the types, I said there are two types of chi-square test: goodness of fit and the chi-square independence of attributes. So goodness of fit meaning is you are having only single categorical variable with the multiple categories. There you are looking for whether the frequency is equally distributed in all the categories or not. So that way you want to make your hypothesis like there is no significant difference in the observed and expected frequencies. Next says second type of chi-square test is independence of attributes, where we will be having the two categorical variables, and as we are from the name it is very clear to us, independence of attributes. So whatever two categoricals you people are considering, you need to see whether those two variables are associated or independent of each other. Then there is a concept of contingency table. Contingency table is nothing but it is a two-way table. Two-way table meaning is, as I just made, this is a two-way table. Your one categorical variable, which is gender, is in the row, and the smoking preference is in the column, right? So we were having total two categorical variable. One will be in the row, second will be in the column with their category. So this is known as the contingency table. So this table is very helpful in case of the second kind of chi-square test, which is independence of attributes. So in case of Excel sheet or in case of Excel workbook or the statistical analysis using Excel, always you need to create this kind of table for your data if you want to apply chi-square test using Excel. In case of other softwares, we do not need to go with this. If our data is in the column, we can also perform chi-square test very easily. But in case of this Excel, you need to convert your columns into this particular contingency table form. Is it okay? Clear to all?
Ma'am, one question is there.
Hmm.
So here you have written the leveling you have done, that is for male and female, this is gender.
Hmm.
And for yes and no, that is smoking.
Hmm.
Now this gender and smoking leveling should be in always in that one cell or in different cell.
Obviously, in different cell.
Okay.
Individually, we are looking for how many of male are liking
Okay.
the smoking or they are doing smoking, how many of them are not doing. So it will be
Mm-hmm.
in a different cell.
Yes, it's like a 2D now, ma'am. 2D
So that
structure.
is why I said it's a two-way table.
Yeah.
One
Okay.
variable will be in your row, one variable will be in your column. So
Column.
variable which you are taking in a row, so all the categories will be listed in a different row. Variable which you are taking in a column, all the categories of that column variable will be in the different columns.
Okay. Thank you, ma'am.
Yeah. Anything else? Shall I proceed?
Yes, ma'am, you're good to go.
Yeah. After this, the sheet which I provided to every one of you, you need to open that sheet. The sheet is named as demo GOF, demo goodness of fit test. You need to open this sheet. Opened? Everyone?
Yes, ma'am.
Okay. So shall I proceed? May I go ahead? Everyone ready
Yes,
with the
ma'am.
sheet? Yeah.
Yes, ma'am.
Fine. So I think I'm just stop sharing my screen for the first time because I think I need to share my complete screen. Otherwise, once I'll go to this data tab, it will not be visible to you people, right? So give me a second. Yeah. Again, I think I'm back with my sharing. And now I think sheet will be visible to every one of you. Here I'm talking about the first table or the first question which I have given to you. In this particular question, you can find the problem is the table shows the number of peoples absent on a particular days in a week, right? So suppose I'm talking about this is from the point of view of any school or college. Suppose here you can find the absenteeism in the schools and colleges, right? So it is written we are having total 5 days, Monday to Friday, and these are the number of absentees according to the days. Monday 125, Tuesday 88, Wednesday 85, Thursday 94, and Friday 108. So this is the observed frequencies, observed numbers given of the absenteeism on the daily basis. It is okay. It is clear to everyone.
Yes, madam.
Fine. I think your data will be till this only.
Yes, yes.
Fine. Now, once we are having the observed frequencies in case of chi-square test, you need to find or get or calculate the expected frequencies. When you are having the other software, in that case, this process you do not need to do using any function or manually. But when you are having the Excel, you need to perform this particular step. So you need to calculate now expected frequencies. So you can write here in your sheet also. You can mention this thing expected frequency is equals to average of observed frequencies. Done?
Yes, ma'am.
So I'll come here. I'll take a average. We have seen the average function previously. Yesterday only I talked about. So I'll select this range and I have made the range static using this dollar sign. So you can use function F4 key or maybe only F4 key. Using that you can apply the or you can make the particular range static or constant, or you can freeze this range. Why we have done this? Because once you are dragging the same formula till the last cell, that way this particular average will not change, right?
Yes, ma'am.
Now I'm dragging this till the last cells. You can find we are getting 100 because average is 100. So we are expecting that the average count will be 100 for all the 5 days. Done?
Yes, ma'am.
Fine. After getting this, now, yes,
Ma'am,
yes.
I want to ask: is there a concept or a sample size related consideration when we do chi-square? Sample size related consideration, is it required?
Usually, sir, for non-parametric tests, we are assuming that sample size should be large because there is one assumption in case of chi-square test, which says the expected count should not be less than 5 in at least 80% of your cells. So when your observed frequency will be high, only that way you can able to manage this particular assumption of chi-square test. I think you got my point. In 80% of the cells, the observed frequency count, the expected. Yes, sir. Just a minute. Yes, extremely sorry. Actually, I am in a college only, so I'm taking the session from here only. So extremely sorry for that. Okay, I'm coming to the question. The question asked by sir. Sir is talking about the consideration of the sample size or something in case of chi-square test. So I said the chi-square assumption says in at least 80% of the cells, the expected count should not be less than 5, right? So you can see how many cells I am having in this particular example.
5.
Total 5.
5.
So the 80% of the 5 will be 4. So in at least 4 cells, the expected count should be 5 or more than that,
Okay. Thank
right?
you, ma'am.
Yeah. So that is why you need to see this thing. Generally, in case of chi-square test, we are assuming that the in each category, the count should be at least this much, so that expected count should not be go down to the 5. Fine.
Yes, ma'am, this point is clear, ma'am. But, ma'am, what about the normalcy of data? Like in other tests, we have this consideration that data should be normally distributed and that particular concept comes.
Uh, okay, sir. I don't know when you have joined the session. Initially, I started with this only. Non-parametric tests are the tests which are not bothering about the normal distribution of the data, because we are talking about the categorical data. Categorical data is not going for the normal distribution. When you are having the numeric variable, then you are concerned about the normality of the data.
Okay, madam. Thank you.
Yeah. So shall I proceed?
Yes, madam.
Yeah. Now we are writing the hypothesis here. So the hypothesis will be there is no significant difference in the observed and expected absenteeism numbers. And your alternative will be there is a significant difference in the observed and expected absenteeism numbers throughout or across 5 days. Okay? Is it okay? Friends, say yes or no.
Ma'am, just can you repeat that formula that you have done? It was F4, right? Control F4 or just F4 for static?
For making this freezing, for freezing the range, you need to use a function F4, depending how it works. Function F4
Oh,
you can take, or maybe F4 only. So you need to
okay,
see in which way it is working in your laptop.
no problem. Ma'am. Done. Thank you.
Manually also you can do if it is not working. But I think when you F4 is there, so shortcut is better.
Okay, ma'am. Okay, ma'am.
Yeah. So I think hypothesis is clear. We are assuming now, if suppose level of significance is 5%. At 5% means we are taking the risk of 5% when your null hypothesis is true and you are rejecting it. So that chance is 5%. This is what you are saying. So at 5% level of significance, now you need to see what chi-square says to you. Manually, if you want to go for chi-square test, this is the formula written here, which is saying O minus E square divided by E. O is observed frequency minus expected frequency. So you can take the difference of this, you can square that difference, and you can divide that square by the E value. So that way, the sum of that particular will give you the value of chi-square. This is the manual process, right? But I think something or what I can some proportion you need to do manually. That is the calculation of this chi-square test, expected frequency. Now we can perform chi-square test using a function. So this particular function which we are using, this will give you the value of P. P is the probability value, the significant value you are getting here, right? So for that, I'm putting a equal sign and typing chi-square dot test. So according to the version, you need to see this. Done. So according to the version, it can vary also. If your version is older, so maybe you can find CHISQ directly test, means without this period, without this dot also, the function may be available. So you need to see whether which version you are using. I'm using the 16th version of Microsoft Office. So in the previous version, if the function name is CHISQTEST. In this and the latter version, this is CHISQ.TEST. Done. Everyone has found. May I proceed?
You're right to go, ma'am.
Yeah. Now it is asking you to provide the actual range and the expected range. Actual range means the observed frequencies. So you need to select the range of the observed frequencies. In my case, it is B3 to B7. After the comma, you need to select the range of your expected frequencies. That is C3 to C7, and then close the bracket. Done. Everyone okay? Fine. Shall I press enter?
Yes, ma'am.
Yeah. So this is the p-value we are getting, 0.027. I hope everyone is getting the same.
Yes, ma'am. We got the same value.
Right. Thank you, ma'am. So now if we are getting this p-value, we need to make an interpretation whether we are accepting or rejecting our null hypothesis, right? So this is you need to compare with your level of significance, which is 5% or 0.05 or 0.05 or 0.05, right? So this is your level of significance. So if I compare this, I can say this is less than 0.05. Yes or no? Yes. I think comparison is quite clear. It is 0.02, it is 0.05. So this is less than from 0.05 or no? Yes or no?
Yes, yes.
Yes. Now I'm writing the thumb rule here. Those who are good with these thumb rules, it's good. If not, you can note down the thumb rules. Thumb rule says if p-value is less than your level, less than or equal to, also you can use less than equal to your level of significance, you need to reject the null hypothesis, right? Then if p-value is greater than your level of significance, then accept the null hypothesis. This is the thumb rule says, right?
Excuse me, ma'am.
Yes, ma'am.
Ma'am, can you just repeat this thumb rule once again, please?
I think it is written there in the on my sheet. It is not visible.
1 minute, ma'am. Yeah, ma'am. Now it is visible.
Yeah,
Thank you.
yeah. So p-value is less than equals to level of significance leads to the rejection of the null hypothesis. P-value greater than level of significance leads to the acceptance of your null hypothesis, right? So now, according to our output, which is 0.027, I compared this with the level of significance, which is 0.05. So I think it is quite clear that my p-value is less than to the level of significance. So that means what we need to do, we are, what will be our decision?
So we are going to reject the thumb rule.
Yes. So
That is,
we
reject our hypothesis.
yes. So we do not accept the null hypothesis, or we are rejecting the null hypothesis, right? So when we are rejecting the null hypothesis, we are concluding that there is a significant difference in the observed and expected absenteeism numbers. So observed and expected absenteeism numbers is different. They are not similar. Is it clear? So accordingly, now the schools or maybe colleges can see individually when you're comparing or when you're seeing the difference is existing. So you can see the difference is 25 on Monday, on Tuesday it is 12, on Wednesday it is 15, on Thursday it is 6, on Friday it is 8. So that way, accordingly, the schools can make the policies and can take that how they can ask or maybe can what kind of things they can involve or they can introduce in the schools and colleges, so they way maybe this numbers can be go down. Okay, fine. Fine, everyone.
Yes, ma'am. Ma'am, can you please scroll down your that is sheet little bit?
It is fine.
Yes, ma'am. Just little bit scrolling in the left to the left. Yeah. Okay. Thank you, ma'am.
Okay. Okay, what about others? It is done, everyone.
Ma'am, if you can explain the thumb rule once again, it would be great. Sorry.
I think it is very clearly written. If
Yes,
p-value
but
is
with an example, it would be great. With the
example,
same example.
I think you can see in our case
Yeah.
0.02. The level of significance we have assumed 5% or 0.05. So I have clearly written our p-value is less than to the 0.05. So this is the case. This is the first case. That means we are rejecting the null hypothesis. Similarly, if your p-value is 0. Suppose it is 0.08. So it is greater than 0.05. In that case, you will accept your null hypothesis. That's all. So you need to always compare what level of significance you have set. That we need to compare our significant value or the p-value from that value, and that way you can make your decisions. So this is an example. So I'm deleting this. Maybe you may confuse also from where I have written this particular value. So this is just an example.
Thank you very much, ma'am.
Yeah.
Thank you very much.
Thank you, ma'am. It is fine, everyone. Two more functions I have written in your sheets. Maybe I think I have given to your sheets also. You can find this. Manually, again, I'm repeating this. I'm not knowing your background of any one of you, that how much you are involving in statistics, whether you have done statistics manually or not, right? So once we are talking about the manual calculations, right? In that case, you need to have the chi-square value also. So chi-square calculated value or the um, I think it's calculated value only, and we need to compare the calculated value from the critical value. Critical value meaning is the table value, the standard value of chi-square, right? So if you want to get those two values, so for that also there is some other thumb rule. If you want to get those two values, so these are the functions I have written here. For getting the critical value function is CHISQ.INV. Inside this function, you need to give your confidence level value and the degrees of freedom. So degrees of freedom in case of goodness of fit is n minus 1. So whatever number of categories you are having, that -1 will be the degrees of freedom. So in our case, you can find we are having 5 days. So 5 minus 1, 4 is the degrees of freedom, right? And confidence level is what? Anyone? It is 1 minus level of significance. So we have set level of significance as 5%. So 1 minus 5% is 95%. So here we need to write 0.95, comma 4. So this will give you the critical value, table value of the chi-square. To get the calculated value of chi-square, you need to use function CHISQ dot INV dot RT. In this, you need to provide the p-value. So p-value we have just received here. This is 0.027, and then comma and degrees of freedom, which is 4. So once you are pressing enter, it is giving you the calculated value of chi-square. So you can make comparison in critical and calculated value to decide whether you are accepting and rejecting the null hypothesis. So this is the other way of acceptance or rejection of the null hypothesis. It is clear? Maybe I may be fast. You can ask me to repeat on from wherever you are getting problem. You can ask me, or maybe one way also you can go for, because software are generally giving you p-values. Yes.
Ma'am, I have a doubt in critical value, ma'am. The formula in critical value. Can you show by numerically?
Numerically, or I need to implement what you want to me to do so.
Ma'am, you can implement the
Okay.
formula.
It is CHISQ.INV, right? Probability meaning is the confidence level, which is 0.95. Degrees of freedom is 4. This is your critical value of chi-square. For getting the calculated value, you can write CHISQ dot INV dot RT. Here you need to provide the p value, comma, degrees of freedom. Done?
Okay, ma'am.
So in case of this type of calculations, the thumb rule changes. For the manual calculation, thumb rule is different. So if you want, I can write, or if you want to go with the p value, I'm okay with both, as you say.
Ma'am, we would like to have the thumb rule for to assess from critical and calculated p-values.
So the thumb rule says in this case, if calculated value is less than your critical value, accept the null hypothesis. If calculated value is greater than your critical value, reject the null hypothesis. So it is opposite to this. So in our case, you can compare our calculated value is greater than to the critical value, right? So we are rejecting the null hypothesis. Results will always be same. Thumb rule is the opposite, right? So whether you're going with this rule or whether you're going with this rule, it will not change your results. Results will always be same. Fine, everyone. Shall I proceed?
Yes, ma'am.
Fine. So this is about the goodness of fit. Next sheet I have provided you for the practice purpose. If you want to do a practice on a separate problem, you can do this. or else you can use the similar problem again for the practicing. Then I'm talking about the second type of chi-square test, which is given in the next sheet, named as the demo IOA, independence of attributes. So open this sheet. Sheet has opened by everyone. Shall I proceed?
Yes, ma'am.
Fine. So independence of attributes is talking about we will be having the two variables. So we are having the two variables, wealthiness status of the people and their graduation status, right? So there you can find we are having the status, the person is wealthier or not, whether the person is middle type, middle wealthier or the poor person. Then education, graduation is having, means people are having the graduation or people are not having the graduation. This is the data which we are having, right? Now, if you are having the data in this particular form, using this data, you need to create your contingency table, right? For making the contingency table, I think I have already written one variable is in the row, that is the status of the wealthiness, wealthy, middle, and poor, and whether the person is having the graduation level or not. So yes and no. Now, in the combination of these two variables categories, we need to write the count here, right? So purposefully, I have applied here this filter. So you can use this filter from this home tab. After this, you need to go to this drop down. You can select this drop down and then you can deselect all. And suppose I'm selecting firstly the wealthy. I'll click on OK. Fine, everyone. I think filtering is not tough. Everyone knows how to do this, right? So I've selected only the one category, wealthy, and clicking on OK. Under this graduation level, I am selecting only the yes. So I can select my filtering range, which is giving me the count is 6. You can see count is coming here, the 6, right? So wealthy and yes combination is 6. Similarly, I am making this as no now. So which is count is 5. So it is 6 and 5. And then I'm selecting all. Okay. And I'm writing here 6 and 5.
Ma'am, sorry for the interruption. Actually, ma'am, your screen is not visible.
Is it?
Now is it visible? Now it's visible.
Okay. So I think for wealthy, we have done a count 6 of the persons, those who are having the graduation level or those who are having the graduation degree, they are wealthy, and 5 are not well. 5 are not having the graduation degree, right? Now I'll come back to this particular first column and again clicking on this drop down. Instead of wealthy, I'll select now the middle and click on OK. In the graduation level, I'll select only the any one level first. Suppose yes, I'm selecting. So I'll select this range, which is coming as 9. So middle and yes combination is 9. Then instead of yes, I'm selecting no. So it is 7. So it is 9 and 7. So I'll write here it is 9 and it is 7. Then I'll come to the poor category. So I'll again go to this drop down, deselect all and select only the poor. Then in the graduation level, I'll select yes firstly, and then I'll select the range to get the count, which is coming as 5. Then I'll go with the no. So it is 6. So it is 5 and 6. Then I'll need to select all the categories. So I need to make my data as the previously I was having. So it is 5 and 6. So this is the count I got. After this, I'll get the row total and column total using the sum function. So I'll select this, enter this, and then I can drag this. So I'll come here and I'll now do the column total. Done? Done, everyone? Is it fine? Was it okay? I think I'm not getting any sounds.
Yes, ma'am. Please, please.
Performed by everyone?
Yes, ma'am.
Yes,
Very,
yes, ma'am.
very good. So I was little worried about this only. If you got it, is good. Now, after making your contingency table, you need to create one more table. So I think I have already given you the format. There you need to calculate the expected frequencies. So I hope I can go with yes. Shall I proceed for the calculation of expected frequencies? Friends, yes or no?
Yes, ma'am.
Fine. So you need to see here in case of in this contingency table format or in case of independence of attributes, the calculation of expected frequency is based on this particular formula, which says E equals RT into CT divided by GT. RT means row total divided by row total multiplied by column total divided by grand total. So suppose I think in mathematics, matrix we all have studied. Yes.
Yes, ma'am.
So if I say E11, E11 meaning is what? It is a first row, first column element, right? So if I'm saying this will be your E11, right? Or maybe I'm writing here, this is E11. This is E12. This is E21 and this is E22. Fine. I hope it is clear. First row, first column, first row, second column, second row, first column, second row, second column, third row, first column, third row, second column. It is fine?
Yes, ma'am.
Right.
Yes, yes.
Please,
So,
actually, your screen is not visible. I don't know why. Can you please
I
help me
think if
out?
it is visible to everyone, so I cannot do anything. Anyone who can tell me my screen is visible or not? Everyone, it is visible or not?
Yes,
Now
ma'am,
it's
it's visible,
visible,
ma'am.
ma'am.
Okay, so Mandrita ma'am, I think you need to pin my screen.
Okay.
So you can check in this participants list if it is there. So from there, you need to pin my screen. Fine. Shall I proceed?
Yes, ma'am.
Yeah,
Proceed.
fine. So I think you understood this concept. So we need to calculate total 6 expected frequencies, right? So now, if I talk about the formula which you need to use or implement to get the E11. So E11 meaning is the row total of the first row. So first row total divided multiplied by first column total. So that is 11 multiplied by 20 divided by grand total is this. So your grand total value is 38. Is it clear? This is your grand total. Okay. Fine, everyone. This is row total 1. This is row total 2. This is row total 3. I don't think so I need to write in this manner. It is fine, right? Still, I have written to make things easier for you. Is it okay? Everyone say yes or no. Shall I proceed? Everyone say yes or no.
Yes, ma'am.
Yeah. Now I'll come to this E11. Here I'm putting the equal sign. So E11, everyone knows I'm talking about Valdian. Yes, for this I'm calculating the expected frequency. So the row total of first, that is this. Maybe you can keep it in a bracket. So I'm selecting the row total, multiplying this by the column total, and dividing this by the grand total. Done. Fine, everyone. Shall I proceed? I'm not getting any confirmations. Please say.
Yes, ma'am, we can proceed.
Yeah, actually, you need to tell me because I'm telling you through the function, so I don't know how many of you are able to get it. Pressing enter. This is the expected count for the wealthy and yes. Now we are moving for the no. Putting equal. So no is again wealthy and no. So it is again the first row. So the row total of this multiplied this by the column total. So 5 is belonging to the second column. So second column total you need to select, divide this by the grand total. Done? May I press enter?
Go ahead, ma'am.
Good. So we got this. Coming to the next row, second row, putting equal. So now I'll talk about middle and yes. So putting equal. So this is belonging to the second row. So second row total multiplied by first column total divided by grand total. Pressing enter. Coming to the E22 equal second row total multiplied by second column total divided by grand total. Pressing enter. E31 third column, third row total multiplied by first column total divided by the grand total. Enter. Putting equal. Now the third row total multiplied by second column total divided by grand total. Pressing enter. Done. Everyone is getting almost similar figures what I got.
Ma'am, can you show me the middle one?
This one.
Yes, ma'am.
So I think you can see the selection H6, F8 and H8. Second row total, first column total and the grand total. Coming in the middle and no, you can see second row, second column and grand total. Done?
Yes, ma'am.
So I'm moving ahead now. Now I think once we have calculated all these frequencies, now we will go for the p-value. So p-value is same function you need to use CHISQ dot test. You need to use the same function and then carefully only select the frequencies cell. So that is why I think this is the I have highlighted. So only this particular range, that is F5 to G7, you need to select. Putting a comma. Now select the range of your expected count and then close the bracket. Do not go for the total selection. So this total section selection you do not need to go. Only select these frequencies. Yes, no frequencies from the observed frequency table and from the expected frequency table. Also, you need to do the same. Done. I think our ranges will be same. I have provided you the same table or the same area was fixed. So will be getting the same ranges. It is F5 to G7, comma K5 to L7. Done. Done, everyone?
Yes, ma'am.
So this is the p-value which I'm getting. I hope everyone is getting the same. Yes.
Yes, ma'am.
Okay, so if this is a p-value and level of significance is suppose your 5%. Okay, so can you tell me what will be my decision? What should be my decision here? Yes. Yes or no?
Accept the null hypothesis because p-value is greater than 0.05.
Very correct. We are accepting the null hypothesis here because our p-value is greater than our level of significance. So I think we have not write our null hypothesis. We have written already. I think it is written in my sheet. You can check at the bottom. It is written. Yes. Wealthiness status is independent of graduation level, or there is no association between the wealthy or wealth status and the graduation status. So we are rejecting the null hypothesis. No, we are accepting the null hypothesis, and we are concluding that the wealthiness status is independent of education level, or maybe you can say there is no association between wealth status and graduation level. Means whether the person is having the graduation level degree, it is not deciding whether the person is wealthier or not. Is it okay? Clear to everyone?
Yes, ma'am.
Any doubt so far? Next sheet I have given you for the practice purpose. Using the sheet you can use, or you can go for the practice, right? So if you want to get that experience, you can do so. So I think I can go for the summarization of the session now. Any questions so far? Or at the end of the session I'm taking the questions. Now I'm going for the summarization of the what we have seen today. So if I talk about today, I started the session with the non-parametric test, where I told you non-parametric tests are the tests which are not bothering about the normal distribution of the data. Because in case of normal or in case of non-parametric test, generally we are considering the categorical data. So in case of categorical data, there is no need to check its normal distribution, right? So we can skip that. Now, further, after understanding the concept of the non-parametric test, I told you there are various tests available under this category. Among them, one test is the chi-square test, which we discussed today. So we have seen what is chi-square test. So chi-square test is generally looking for the distribution of the frequencies, whether the frequency distribution is uniform or not. This is the main concern, right? So in this particular process, we need to have to see that how many types of chi-square tests are available. So I said there are two types of chi-square test: the goodness of fit and the independence of attributes. So in case of goodness of fit test, जा रहे हो आप? Okay. So in case of goodness of fit test, if I talk about, you need to see, I said we need to have only one categorical variable. So one categorical variable we will be having, and we will be having multiple categories in that categorical variable. So we are looking for that frequency is same for all the categories or not. So that is the purpose of goodness of fit. Second variation in the chi-square test is about the independence of attributes. So in case of independence of attributes, we will be having the two categorical variables, and we are generally looking for that both the categorical variables are having any association or not. So whether the two characteristics of the individuals are similar or not, this is what we are looking for. So that way you need to understand the concept of contingency table, which is nothing but which is a two-way table, in that you are putting one variable on in a row and second variable in a column with the categories. And you need to always get this row total and column total in case of the Excel, because in Excel you need to perform the expected frequency count using the functions, right? Or using the formula. So that way we have seen that formula of the expected frequency in case of independence of attributes says row total multiplied by column total divided by grand total. So that formula we have applied here to get these values. And after having these two values with you, you need to only perform the p-value function, which is the chi-square dot test, and then inside the brackets you need to give the range of your observed frequencies and the expected frequencies, and you can press enter to get the p-value. And thumb rule of the p-value, or a thumb rule based on the p-value, I have told you whether you need to accept and reject the null hypothesis. So in which case you are accepting, in which case you are rejecting, that I explained you. So this was the gist or the summary of the session today, what I explained to you. I think now rather than taking the test because it will be altogether a different thing. Now I'll ask you if you're having any queries today, what I discussed with all of you. So you can please ask me the questions and then we'll wind up the session. Any queries you are having, most welcome. Yes. Now I think session is open for questions. If you're having any question, you can please ask me.
Ma'am,
Yeah.
what chi-square test, is it very important if we think about research point of view? Is it necessary to do that test and predict the analysis also there whenever we require?
Ma'am, it is totally depending upon your objectives of your research. If your research objectives are based on the categorical variable, in that case, you need to perform. If your objectives are not stated like that, so in that case, no need to go for the chi-square test. Always, every research is based on your objectives. Objectives are leading to your hypothesis. So accordingly, you need to see what kind of data or what kind of objectives you have framed. And that way you can collect, because a questionnaire development is a letter on a stage, right? So
Right.
firstly, you are defining your objectives. Objectives are leading to your hypothesis. So once the variables are clear to you, accordingly you are making your questionnaire and that way you are collecting the data. So it is depending upon your objectives.
Okay.
Not mandatory every time that you need to go with.
Ma'am, second and last question, ma'am. As we have done this whole process using certain formulas, where I was seeing in data analytic tool pack, we don't find chi-square.
It is not available. That is why today I
Yes,
told
ma'am.
you this. Yes.
Can we do it like we are using Excel? But can we use another tool like SPSS and do through that also? It will be
No,
okay.
this FDP is dedicated only for the Excel, ma'am. So that is why I
Yeah.
told you in this manner. But we are having
No
other
problem.
softwares. Yeah, other softwares can do that for us.
Okay. Okay. Thank you, ma'am.
Thank you, ma'am.
Good evening, ma'am.
Good evening, sir.
I am from Bhilwara, Rajasthan.
Yes.
Currently, I work at the R&T College, Kapasan.
I think you're not audible to me. Ashish,
Near
sir.
Udaipur.
Yeah.
Yes, sir. Yes, ma'am. Yes, ma'am.
Yeah.
Can you hear me?
Yeah. Now I can.
Ma'am, what is the role of pivot in research point of view?
Pivot table can only help you to summarize your data.
Okay,
Or
okay.
means at max you can go for the descriptive statistics and not beyond that.
Okay, ma'am. Thank you.
Thank you, sir. Any other question?
Okay, ma'am. Thank you so much. Again, wonderful session.
Thank you, Ajay sir. Sir, what happened today? You are there in a session?
Yes, ma'am. I am something learning from you.
Okay. It's good when I'm talking to you, sir. I mean, it
Yes,
was
yes,
like
yes, sir.
usually you're not getting time and coming in the sessions, right? So I was thinking today how you are there.
But ma'am, I will try to attend maximum session.
Okay. Okay, that's great.
Thank you so much, ma'am. Thank you.
Thank you so much,
So,
Ajay sir.
thank you all participants. Thank you.
Thank you. Thank you, everyone. Good night. We are meeting tomorrow for the next session. Take care,
Thank you,
everyone.
ma'am.
Good night,
Thank you.
good night.
Yeah, good night.
Thank you. Thank you, ma'am.
Thank you, Miral ma'am. So, Ajay sir, may I leave the session now?
Yes, ma'am. Please, please.
Yes,
Thank you
ma'am.
so much, ma'am. Thank you.
Thank you, sir.